Today I'm going to show you how to make a custom steering wheel. Now this project is going to be a little bit of the extraordinary. I'm going to show you today how you can make a aftermarket or a custom steering wheel, or even better, a steering wheel that's out of production for a vintage vehicle. This is a bit of a complicated project, but I wanted to show you how you can do some of this on your own without much complication, actually. And here you can see me installing the finished project. So this is actually where we want to be when we're done. To start our project, we first need to cut down some plywood and create a working surface. And while we're at it, we're going to also create a backer board that we're going to use as a support shell in this cavity pour on one side. Here is our steering wheel. We're going to trace that onto the working surface. Keep in mind that one of these boards is going to actually become one half of the support shell, and we're going to need to actually trace the steering wheel, make sure everything fits, and then we're going to proceed by cutting some holes into it. These are going to become holes for the bolts. This is where the bolts are going to go in that hold the two halves together. And then the bigger holes on the actual steering wheel diagram, those are going to be holes where we're going to be pouring the silicone into the first half of our mold. As you can tell, the steering wheel is very three-dimensional. It's not flat. And for this reason, we're going to need to build up a working surface. Now, I could go ahead and use clay, but it would become so heavy. We're going to need about 40-50 pounds of clay to do this buildup. So for that reason, I'm going to use some building foam. I'm going to build up the shape that I need, and then I'm going to put the actual oil-based clay on top. This is Sculptex oil-based clay that I'm using here. And I also like to mention that this is the soft version. There's a soft, medium, and a hard. Obviously, the soft one is the easiest to manipulate. And now, once that clay is built up to a level that I need, I'm going to go ahead and smoothen everything out so it's nice and clean, and the actual mold itself is going to come out clean as well. Now, any gaps between the steering wheel and the clay buildup need to be closed off. So I'm going to use some more of the Sculptex clay. I'm going to roll it into little snakes, and then I'm going to go around the perimeter, fill any gaps with this clay, and then I'm going to come back with a wooden tool. It's really important then when you're working on soft surfaces to use wooden tools so we don't damage the original. I'm going to clean that edge up, because the cleaner edges that we have, the cleaner castings we're going to get out of that mold. We're going to put back our support shell on this side, and we're going to mark where those bolts are going to go in. And once we mark those down, we're going to remove the support shell, and we're going to actually insert the bolts into the clay. What I'm doing here is I'm basically putting these bolts in as space holders. They're going to actually create the holes where the bolts eventually will go in. Now, before I put all the bolts in and I don't have any room to work with, I'm going to go around the perimeter of our model, and I'm going to put some keys into it. These are negatives, and they will become positive keys once we pour the silicone into it. Besides the keys, we're going to put some vent holes. Vent holes are one of the most important things about your mold. Without vent holes, your casting is surely going to come out with air voids, and also placing the vent holes in the wrong place will cause the casting coming out of that mold to have air voids and air bubble trapment. Now, keep in mind, you should plan your mold and lay out the main vent holes where you want them to be, but also keep in mind that you can cut vent holes and vent channels into your silicone mold once the silicone is fully cured. A pour spout comes in here. We have a place to pour the material. And then one more quick fitment to make sure everything fits right. And then we can move on to the assembly of the mold box. Now, before we go to that step, there is one more thing that we need to address here. Where the airbag goes, there's quite a deep hole. And pouring all that extra silicone is not really necessary and will actually make the demold of our project a lot harder. So therefore, we're going to make a plug. that's going to be attached to the support shell surface. And for this plug, we're going to be using the EpoxyCast 670 HT. Now, why are we using the HT product here? It's a high temperature product. And because we're going to be heating up the mold in our casting process, we do need to have some temperature resistance. As always, keep the end result in mind. What's our end goal? And knowing and understanding that we're going to need to heat up the mold is a part of that. Now we're going to go ahead and dispense the EpoxyCast 670 HT. This has a mix ratio of 108 to 16B, so we do need to use an accurate gram scale. And then we're going to mix the two components thoroughly together by scraping the sides, scraping the bottom off our mixing container. And then we can simply dispense it into our pre-marked cup that has the level of the height that we're going to need for that cavity to be filled. The material is now allowed a full cure for 24 hours before moving on to the next step. It's been now 24 hours and the EpoxyCast 670 had a full cure time and can be now removed from its mold to be joined with the support shell. And we're going to mix a little bit more of the material. Same procedure, use a gram scale. And this is going to become our adhesive, so to say. We're going to glue the plug that we made onto our support shell surface. Now, this is now allowed a full 24-hour cure before proceeding on to the next step, and that is the assembly of our mold box. And here you can see I'm using some melamine boards that I'm going to put around our buildup. I'm going to use some hot melt glue to hold those together. And you always want to make sure whenever you're working with cavity pores like this, and that's exactly what this mold is going to be, to make sure all the crevices and all the gaps are shut so no silicone escapes. Here in the bottom corners, I'm going to use these angle blocks that I actually cut a little lower. That's where our support shell is going to sit on. And on top of our mold, I'm going to put some bolts in there with some washers. That's the other side, and that's what the support shell is going to sit on. Now, because our support shell is made out of wood, we want to make sure that the silicone doesn't stick to the wood. It is porous. We're going to seal it with some sonite wax. Let that dry for about 20 minutes. And then we're going to put our mold box and the support shell together. Now we successfully created a cavity. So we can now skip to the next step. The MoldStar 30 has a very convenient 1-to-1 mix ratio by either weight or volume, so no gram scale is necessary. And the working time of 45 minutes allows us plenty of time to mix and pour a large quantity of material. And again, to understand what we're working with, the MoldStar 30 is the recommended silicone that we're going to be using for our mold, because the Crystal Clear 220, that's what we're going to cast our steering wheel with, calls for this specific material. So before dispensing, of course, pre-mix the A and B separately, stir that up thoroughly, break it up, and then we can go ahead and mix the two components together. Now here I'm using a 5-gallon bucket because we do have a lot of material, and I'm going to be using a turbine mixer with a drill. It helps us with the mixing process. Because it is a lot of material, it makes it a lot easier to mix that material. When I'm done with the mixing with the drill mixer, I'm still going to go back with a handheld mixing stick and scrape the sides and scrape the bottom to make sure that there's no unmixed material. Now we can proceed to pour the silicone into one of the openings. And we're going to pour until we basically see the silicone reach the level of those vent holes. And once that is achieved, we're going to put a weight on top of that, make sure that that wood doesn't just float. And we're going to now allow this a full 6-hour cure before moving on to the next step. Now our next step would be to make the other side of the mold. That's going to start with removing all of the clay and the foam that we build up. As always, recycle your clays because you're going to use them for other projects. And try to keep that mold box intact as much as possible because we're going to need it for our next step. The bolts that held the place are removed. Any clay is removed. And any clay residue is thoroughly cleaned. Now, to prevent the clay that we're going to build up onto the steering wheel from getting the steering wheel dirty again, we're going to put some saran wrap down. And basically what we're doing is we're going to build clay over this to create the second half of the support shell. Everything that was clay is going to become a cavity where we're going to pour the silicone into. Now I'm going to put some dowels into those holes from the bolts. Again, these are space holders, just so we can work around these and we don't clog them up because we are going to need them in our mold making process. Now, I do need to build up at least 1.5 inches of thickness of clay, and for that I'm using a board that I set up. The two boards on the sides do have the desired thickness that I want the clay to be. And I'm going to simply start by squeezing some of that clay on top of a saran wrap. This is going to help me to remove the clay much easier afterwards. And I'm simply squeezing the clay down. I'm going to level it out, and this is helping me create a specific thickness that's going to help us determine the thickness of our future mold. Once you have that built up, you have a solid sheet of clay that's the specific thickness that we're aiming for, and we can now cut that clay up and use it as a space holder on our mold. Again, this is considered a cavity pour mold. So here what we're doing, we're creating a space holder with the clay, and then we're going to build up a support shell on top of that. Once the support shell is made, we're going to remove the clay and pour silicone into that. I'm going to just go around here and apply the clay. Again, this is about 1.5 inches thick. So we're going to smooth out the clay as much as possible. And then we're going to come back and cut those dowels, our space holders. We're going to cut them down to the height of the clay. We're going to insert them back into it. And then we're going to proceed to building up our mold box over this entire structure. Just like we did for the first half, we're going to use some hot melt glue. And remember how I told you to keep that mold box in as many as little pieces as possible. Here it becomes very handy because we have just one piece that we put around the entire perimeter. And then I'm going to proceed to close up any kind of cracks and gaps with some of the Sculptex oil-based clay. And here on the bottom of our mold, I'm putting a plexiglass piece just so it's an easier way to see into the mold for the video purposes. A couple of keys into the clay. That's going to help with the alignment of our support shell down the line when we're reassembling it. And now we're ready to move on to actually make the support shell for this half. To make the removal of the support shell that we're making out of fiberglass and epoxy easier, we're going to put down some Ease Release 200 in a spray brush spray technique. And we're going to spray, then we're going to brush it around with a dry brush, and then we're going to spray one more time the entire area with some release agent. Keep in mind that you want to apply the release everywhere where the epoxy will be touching. The release agent is now allowed 20 minutes to dry before moving on to the next step. And now we're ready to move on to actually make the support shell for this half. I'm using the Epoxamite HT. Again, I'm using a high temperature material because I know that this mold will be going into an oven to preheat, and I don't want it to distort. I'm also going to be using here a product called Urafil 11. This is a filler that's used in urethanes, epoxies, and silicones to thicken material. Basically, what I'm doing is I'm creating my own gel coat that's much thicker than the epoxamide just on its own. Now, keep in mind this is a product that's measured out by weight, so you want to use an accurate gram scale. I'm going to add a little bit of the Urafil 11, and I'm going to mix that thoroughly into the Part A. Make sure it's a nice and thick paste, and then I'm going to add my Part B. Keep in mind we're adding the Part B to the weight of the Part A, not to the Part A and the filler combined. Now, once that is thoroughly mixed, we can go ahead and brush on a layer of this thickened epoxamide HT onto the actual clay itself. Again, this is just to create a thicker gel coat-like coating on the first layer so that we cover basically all the crevices and we have a nice and smooth surface on the inside of our support shell. Now I'm going to let this partially set up for about 2 hours before moving on to the next layer. But in the meantime, I'm going to go back and cut down some glass fiber cloth. And we're going to use this to laminate to create our second support shell. And here I'm first cutting down some actual shape of the entire support shell, and then I'm going to cut some strips that we're going to use to reinforce the edges and throughout the entire buildup of that support shell. Keep in mind that the smaller pieces of glass fiber cloth you use, the stronger the shell actually is going to be. Now we can go ahead and dispense the Part A, dispense the Part B, and mix them thoroughly in a clean mixing container. Now, one important aspect about glass layup like this is the fact that we want to use the same amount of epoxy to the glass cloth. And what that does, it actually makes our overall structure that we're building a lot stronger. Keep in mind that extra or excess epoxy does not add extra strength to the overall structure we're building here. So again, keep in mind epoxy to glass cloth ratio should be about the same. We're going to apply this over the thickened epoxamide layer, and while the material is still fresh and liquid, we're going to start by squeezing some of this glass cloth into the epoxy. Basically, we put the epoxy down and then we squeeze the cloth over it and let the epoxy penetrate the cloth. I'm just going to slowly make my way around and press this down, and then go around the perimeter and make sure that the epoxy saturates fully into the glass cloth. If you have any of the material sticking out as excess, we're going to cut those with some scissors. Again, around the perimeter, we're going to put some smaller strips down. This is going to help with the reinforcement. This is where the bolts are going to go through. And we want to have a little bit of a reinforcement in that area. Here as well, this is going to be the pour spout area for our silicone. I'm going to put some extra cloth around there. Now, I already applied 2 layers. We're going to let this sit for about 2 hours, let it set up, and then we're going to apply a 3rd layer and then a 4th layer of the epoxy and the glass cloth. Once all the layers have been applied, we're going to allow the material to cure fully for 24 hours. Now, the next step would be to remove the actual mold box. Again, keep this in 1 or 2 pieces if possible. Again, we're going to reuse this, so it's much easier to reassemble it in 1 or 2 pieces than all separately. Now, the epoxy glass cloth is sanded down. It still has a lot of sharp edges, and you can easily cut your hand on that, so we're going to sand that down. and then proceed to remove that support shell with the clay. And once that is off, we can go ahead and remove all the clay out of the support shell. And once that is clean, we're going to put it back onto our mold, and we're going to mark down basically some vents for the silicone and then the pour spout itself. So here I'm cutting the actual pour spout out. We're going to drill out the vent holes for the silicone. Basically, we're going to pour silicone up top, and it's going to come out the bottom where you see those vents. But we're going to see that in a second. And we're going to put some release agent onto the silicone itself. This is Ease Release 205. It's a liquid version of the Ease Release 200. The reason why I'm using the 205, it's a lot more potent and a lot more concentrated when you apply it in a liquid version than spraying it all over. And I'm really cautious with this because it's a really important mold. I want to make sure that this separates very well. Whenever you're using liquid release agents like the Ease Release 205, make sure that you don't over apply. So don't let the liquid just sit in a liquid form at the bottom of your mold. Remove any of the extra release agent and allow it to dry for 20 minutes before moving on to the next step. Now, using some hot melt glue, we can simply reassemble the mold box around the first half of our mold. Any of the cracks, crevices, and gaps are filled with the oil-based clay. And then, just like I did previously, at the bottom or here at the top, I'm going to use a plexiglas so we can actually see into the mold as we're filling it up with silicone. So once the mold box is reassembled, we can go ahead and apply our epoxy support shell with the glass now. And this is going to sit on those wooden dowels, the space holders that we put back into the silicone. And then everything is glued together using some hot melt glue so that can't move around. We can go ahead and mix our Moldstar 30. Same procedure is used like we did for the first half. Mix it with a drill mixer, come back with a mixing stick, scrape the sides, scrape the bottom, and then you can go ahead and pour it into our mold. And here you can see how the silicone is now filling that cavity that we set up between the support shell. And in this shot, you can see that the silicone is coming out of those lower vent holes that we drilled into the support shell. We're going to plug those up with some oil-based clay. And it's really a good idea to have some oil-based clay on hand and handy, ready to go. Here you can see that I had a bit of a breach around the perimeter, and the oil-based clay is a great way to stop any of the silicone leaking out. And then we can proceed to pouring the rest of the silicone into our cavity until it reaches the top level, where we're going to plug up the rest of the holes until it fills the actual pour spout. The silicone is now allowed a full cure of 6 hours before moving on to the next step. Now we can go ahead and actually break that mold box apart. We don't care about that shape anymore. We can just break those down. And then we're going to start by removing that support shell. You can see that seal between the silicone and the support shell break. And then we can remove that. Open up our mold slowly. And then we're going to proceed to remove the actual steering wheel out of the mold. So again, you're going to just move slowly, make sure we don't yank on it too hard. You can clearly see here what kind of shape we're dealing for this model, for the steering wheel, and how three-dimensional it is. I'm going to proceed to remove any of the dowels. And then we're going to remove the actual steering wheel out of our mold. Air vents are a very important part of every mold, and this one is same way. We already precasted several channels in here, so now we're going to come back with a razor blade, and we're going to cut the positives away to create a channel where the air will escape through. Now, keep in mind that if you do a test casting and you discover that you're still getting air bubble trapment in certain areas, you can come back and cut additional air vents to prevent the air trapment and get a better casting out of your mold. So there you have it, a really easy to understand step-by-step instructional video on how to actually make the mold for a project like this that seems very intricate and very difficult. Now, if you would like to see the casting of the steering wheel, you can click on the link above, and it's going to take you to the video for the casting. If you have gotten inspired by this video and you would like to make some of your very own molds, you can do so by visiting any one of our distributors around the world. So, and there you have it, a simple step-by-step procedure on how to make a mold of a very difficult steering wheel. Now, if you have an idea about what we should do next, please let me know down in the comments below. If you like this video, hit the thumbs up button. Now, to keep up with our latest mold making and casting videos, remember to subscribe.